our client knew which customer they should approach first. So in the deep learning definition, deep learning, what is the deep learning itself? So it consists of several layers of neural network designed to perform more sophisticated tasks. The construction of deep learning models was inspired by the design of the human brain, but simplified deep learning models consist of a few neural network layers which are in principle responsible for visually learning more abstract features about particular data. So we can have the various examples of this term, and that how it can be differentiated from other scenario, like how this it is going to implement in the real world. Like it is a machine learning training method based on reward desired behavior. Reward desired behavior and or punished undesired ones. Also punished undesired behavior ones. In general, our reinforcement learning agents is able to perceive or interpret its environment, take actions, and learn through trial and error. So here we are having the particular examples like how trial and error is going to perform. So in reinforcement learning, developers devise a method of rewarding desired behavior and punishing negative behaviors. Here we are having the negative behaviors as well. So in the particular behavior, we can understand from the particular examples that while reinforcement learning has been a topic of which interest in the field of AI, what are the fields of AI? Its widespread real-world adoption and application remain limited. Nothing this, however, research papers abound on theoretical applications. There have been some success use case studies. So in-depth guide to machine learning can have the particular so what are the current use case include but are not limited to the following, like suppose we can use the following technology in the games, like gaming, okay, then we can have the particular resource management, or you can say personalized recommendation, or you can say the custom recommendations. Then we can have the robotics also. Then that the gaming is likely the most common usage field for reinforcement learning. It is capable of achieving superhuman performance in numerous games. A common example involved in the game is Pac-Man, and this Pac-Man game is very widely using this technology, this cutting-edge technology. A learning algorithm playing Pac-Man might have the ability to move in one of the four possible directions, bearing obstruction from pixel data. An agent might be given a numerical reward for the result of a unit of travel. 0 for empty state, here they are having particular rewards like 0 for empty space, 1 for pellets, 2 for fruit, 3 for park pellets, 4 for ghost pose, 1 pellets. So reinforcement learning also used in operation research. Operational research. It is used in the information theory. Then it is also used in the game theory. Then it is also used in the control theory, simulation based optimization, then multi-agent systems, its SOM, intelligence, statistics, and generic algorithm, and so on. So what are the challenges of applying reinforcement learning? While high imputation can be difficult to deploy and remains limited in its application, one of the barriers of deployment of this term that its reliance on exploration of the environment. For example, if you were to deploy a robot that was reliant on reinforcement learning to navigate a complex physical environment, so it will seek new states and take different actions as it moves. It is difficult to consistently take the best actions in a real-world environment. However, because of how frequently the environment changes, the time required to ensure the learning is done properly through this method can limit its usefulness and be intense on computing resources. How is reinforcement learning different from supervised and unsupervised learning? So supervised learning, in supervised learning, algorithms train on a body of labeled data, but this algorithm can only learn attributes that are specified in the data set. Common applications of supervised learning are image recognition models. So these models receive a set of labeled images and learn to distinguish common attributes of predefined forms. But in unsupervised learning, here we are having the supervised learning and the unsupervised learning, developers turn algorithm loose on fully unlabeled data. The algorithm learns by cataloging its own observations about data features without being told what to look for. But in the reinforcement learning, this task a different approach altogether. It situates an agent in an environment with clear parameters, defining beneficial activity and non-beneficial activity, and an overarching and game to reach. It is similar in some ways to supervised learning is that developers must give algorithms clearly specified goals and define rewards and punishment.